Hello, my name is Jeremy Woods, and today I want to talk to you about a new Jetpack library, Navigation 3. But first, let's take a look at what we have for navigation today. In 2018, the Jetpack Navigation component was announced, releasing its first stable version in 2019. It is the one-stop shop for all of your navigation needs, with built-in integrations with other Jetpack architecture components such as lifecycle, save state, and view models. The expectation was that it would be expanded as the ecosystem evolved. In line with that expectation, the Navigation Compose library, built on top of the Jetpack Navigation component, was released in 2021. It offers an opinionated solution to navigation within your Compose app. It was a great start to providing out-of-the-box support for an extremely important feature of Compose. But as the idea of Compose began to transform over time, we started to believe that we can take the support for navigation in Compose even further. So in order to create the best integration possible, we went back to the drawing board to rethink our approach and how we could provide a navigation solution that takes full advantage of everything Compose has to offer. To do this, we had to take a step back and think really hard about what navigation is and the role that it plays in your app. Navigation is not your UI. It does not know any of the content that is being shown and should not directly interact with that content. It simply defines when the content should be shown and where to show it. This separation ensures that the navigation library and the content being managed by the navigation library have no requirements of one another and can easily be interchanged. In practice, this might be something as simple as passing your composable function a lambda that handles the navigation instead of a specific component of the library itself. With this approach, no matter what navigation system you choose to use, the composable function can stay the same. You just change the code that you pass into the function. This kind of separation also helps with testing. While your navigation and your UI component should not interact directly, they should be aligned in architecture. A state-based UI should try to use a state-based navigation solution. When you attempt to mix state-based systems with event-based navigation, you end up with some interesting scenarios. Say you have a state-based library, i.e. Jetpack Compose, and you want to integrate with an event-based navigation solution like the previous Jetpack Navigation Compose library. You want to do something simple, like navigating from a home composable to a profile composable. Let's walk through the steps to complete this navigation while keeping up with both the app state and the navigation compose state. If we start on home, both our app state and our navigation state are consistent. In order to go to profile, we need a navigation event to be triggered. This is normally caused by something user-based like a button click. That button click updates the app state immediately to profile and sends an event to Navigation Compose, asking it to navigate to the profile screen. But it hasn't actually changed the navigation state yet. Our states have already deviated. Our app state is profile and our navigation state is still home. What happens if the event fails or is interrupted by another event? This is concerning because we would need to make a judgment call about which is the correct state. To handle these cases, we need well-defined parameters of interaction to ensure we can maintain expected results. Once the navigation event completes, only then is the navigation state updated. Since the UI is observing the navigation state, updating that state is what actually causes the UI to change. While this type of pattern works great with event-based UI systems like views and fragments, in Compose, we feel like we can do a little bit better. Now, let's take a look at this same case using the state-based library like Navigation 3. We will walk through the steps keeping up with the states in the same way as the previous example, except here, the library just always reflects the app state. We follow the same pattern, except for this time, when the profile button is pressed, instead of waiting for an event, Navigation 3 is observing the app state directly. Once the app state is changed, there's no more work to be done. Navigation 3 sees that state as it changes. And that same app state change also triggers the UI to update. We have a single source of truth, and anything relying on this state always knows exactly what it is. When navigation and UI are aligned, it simplifies the interactions and promotes safer practices. So we talked about how you might want your navigation and UI to interact with one another, but what do you actually need for navigation to work at all? You need a container to host the UI. The container can be any size and it can host an unlimited number of content items. Roots or some sort of key to help identify which content to interact with. Preferably this is type safe. A view presenter to receive events that update those roots and properly format the container based on some input. That is all you need to get something working. Then we get into things that make it nice, like animations between screens and shared elements, saving and restoring state, both automatically and manually, and the various overlays that might be useful, such as dialogue, bottom sheets, and other unique UI components. If we know what the parts are and we know how we want them to interact, why do navigation libraries get so complicated? The reason for complexity is that there's no one single solution that addresses all navigation use cases. If the library designs a type-safe route built on a custom class that is user-defined, this works great within a module where you have access to the custom route. But if you want to navigate to a module whose custom route types are not available to you, you really need something more flexible, like a non-type safe string. Either that, or you need to address it in your architecture, which can be a pain for already established applications. Do you keep the state in the library and make the user pass in all updates? This makes it easier for developers getting started, but inflexible for some more advanced users that might want to keep their state in an online repository or database. Then there's the need to handle displaying content on multiple screen sizes. What happens when your application goes from one screen to two? How do you define which content should be shown? Let's say you have a list detail set up, and on a single pane, you are only showing the content for the list. When you swap to two panes, what do you want to show? Should the list be the first pane and then some detail item be arbitrarily added to the second? Do you need a placeholder to be put in place until a detail item is available to be shown from the user? How does the library know which of these is the proper option? The answer changes based on the use case. We've not even begun to look into cases like saving state and handling back. So with all this knowledge of different use cases that need to be addressed, and a desire to improve the library interactions with users, we decided to provide Navigation 3, a new library with the goal of meeting the user where they are. We did a lot of thinking about what we were looking to create with a new library and how we could ensure we were actually building a library for the future. We came up with two goals. 1, embrace compose. This means providing a state-based solution where the developer owns the backstack state, and that backstack state acts as the application's single source of truth. And we should embrace a fully declarative programming model while thinking about efficiency in both writing and reading code. It is easy to think of compose as just a replacement for views or fragments, but that is not the case. It has its own sets of patterns and concepts that the Navigation 3 library should stick to. 2, getting out of your way. If there is anything that we learned by studying the navigation ecosystem, is that you, the user, knows what you need. You know how you want your state to be managed. You know how you want your state to be saved. You know which components you want to integrate with. You know what is your most important feature, and you know what you want to show on the screen. Sure, we can give you some helpful options and suggestions, but it should be easy to replace our opinions with your own. So we're leaning even further into compose patterns. We will provide more building blocks implemented in layers instead of monolithic solutions. If there's any part of the library that doesn't work for your use case or fit your mental model, drop down a layer, add your own implementation, and leave the rest in place. We will provide more recipes instead of hard-coded APIs. It is important to know which strategy to apply in which situation and be able to manipulate that strategy when needed. This ensures that users are not limited to any predefined solutions set by the library itself. And since you can finally own the backstack, it will not be hidden inside the black box of the library, and you decide what its state is at all times. But what does owning the backstack really mean? Owning the backstack means owning the navigation state. We call it the backstack because the navigation state is normally represented as a sort of stack where you move to different destinations and keep a history. And you have the ability to visit previous destinations by removing things from the stack, but you can represent it as anything. It can be a list that adds and removes destinations in arbitrary positions based on information streamed from a repository. It could be a graph that creates a hierarchy that links destinations together based on special conditions. It can be whatever you need it to be to fit your app. But again, because you now own the backstack, this means that you are also responsible for managing it. This means saving and restoring state, mapping state to screens, and even specific behavior like deep linking are no longer able to be handled by the library immediately out of the box. The good part is that between recipes and helper functions, we can provide you some really nice ways to cover the more general use cases while allowing space for developers to create things for their specific architectures. So, what does the future hold? We believe that your navigation should fit your mental model. And with Navigation 3, we hope to provide a library that does just that. You get to choose how to represent your state. You get to choose which components to integrate with. You get to choose what content to display and when. And you can choose to try out the new navigation library, now currently in alpha. Hopefully this video provided some insight into what we believe to be the future of navigation, and you will join us on this journey by checking out the documentation and reading the blog posts, then providing feedback at goo.gle/nav3. Thank you.